Then, okay. Yeah. Okay, welcome everyone. So my talk is about Kotlin mysteries found from years working with Kotlin. So what I did in this presentation is gather 6 different aspects of working with the Kotlin programming language on top of Spring that have led to some confusion, or they were difficult to understand, or they presented different kind of results than what we had expected. So what we are going to talk today, one more moment. I think I'm going to have to continue from the big screen. It's not working because I'm not seeing the screen on my machine. Yeah, I think now. Yeah. So my apologies about this. Okay, so we're going to talk about null safety and how does that affects the way we work with the Spring framework. Then we are going to have a look at inline and cross-inline. What does that mean and how can we visualize that in Java? And what conclusions can we take from that and how can that be useful for us? Then we are having a look at tail-recursive calls. This is probably not a new concept for everyone here, but for typical Java developer, it's not something that we come across very often, and we don't use it in Java because it's just not so readily available. So that's something I want to go through also in this talk. And then we are going to talk about data classes and annotating data classes and how can that make a difference in Kotlin. And then something about delegates. How can we use delegates in a way that we can use them in the Spring framework and see how can that benefit us. And then another thing that I took from DevOps UK, from talks with different people, which is what does it mean now that Java has unnamed classes as an experimental feature in the new versions, namely in Java 21. So very quickly about me, I've been working as a software engineer for about 10 years. I've been doing Java, Kotlin, Groovy, Scala. I have a YouTube channel, and I have different hobbies like plants, and I like reading books, and I've traveling and all kinds of things, but that's just shortly about me. So what I want to talk about now in this topic is null safety. Kotlin promises a guarantee of null safety. Although we can use nullable members in our classes, we really shouldn't whenever possible. And when is whenever possible? So the idea is that we don't want to deal with null pointer exceptions. We don't want to deal with null values in Kotlin. And so Kotlin promises null safety for that. When we are combining that with using Spring, we can get some surprises. And one of them is the one I want to talk about right now. And it is something that comes from typical database models. This is something that I created as a car parts. It has an ID, it has a name, production date, expiry date. And what we normally do in our code is simply do a mapping to a data class. And there we say, we identify this as our table with the name car parts, have an ID. And basically, this normally should work, and it works. And we do the mapping, ID to ID, name to name, production date, expiry date. We do all of this. And then we have data in our database. Data that has a name, everything else that I've mentioned. But there's a second record there where I say that the name is null. What would happen now if we try to map that to our data classes. So I made a test for this. This is just a simple test where I'm going to check if I have any name as null. Name is non-nullable. So this shouldn't even be possible. That's what we expected as ex-Java developers starting in Kotlin. What happens there is that this is indeed possible. This is something we can get in our Kotlin code. And so it's a bit weird because we are reading our code, we are debugging, and we see a null value in a field that is supposed not to be nullable. And so this happens. And what this forced us in our work environment is it forced us to migrate our data, and it forced us to rethink about our model. And in some cases, we had to use nullables. So that means that we didn't take any benefit from null safety in Kotlin in this case. We simply used the question mark next to it. I don't know how many of you are working in Kotlin at this point. Quite a few. So maybe what I'm talking about is not anything new. If you are working with Spring, who is working with Spring at the moment? Who is working with Quarkus? Ktor? Okay, so everyone is working with Spring. So everyone, not everyone, most of you are working with Spring. Any with Spring and Kotlin? Okay, that's a big number. So yeah, so this is one of those things that we found. And the reason why this happens is, of course, because Spring works with injection. It has AOP also, and which behind it uses a lot of reflection. And that is a reason why we get the null values in non-nullable variables, which is something that we can simulate in this piece of code here, where we then see that if we set the value, not assign it, but if we set it, then we can put a null value in a non-nullable field. And this is something that started a discussion the first time I made this presentation by JetBrains, because the idea is, what do we do here? When do we want the null pointer exception to occur? Do we want it to occur at the moment we get the data from the database, or do we want it to occur later on? Because at this point, the way the code is built, and I can show that towards the end, the null pointer occurs during the conversion, when we are converting our entity to a DTO, because that's when we try to assign a null value to a DTO that also has a field that is not nullable. So we get the exception much later on than when we should get that exception. So that was for nullables. Then we've got this inline and cross inline. I don't know how many of you know what this is, inline and cross inline. Not many people. Yeah. So inline and cross inline. Any of you know what the definition is of inline, of what it is about? No. Okay, so inline, in this case, what it does is it's literally inlines the code. For every point call to our code, it makes a copy of the bytecode of that method. So the body gets copied in different parts of where the call is made to the code. So why does this matter? Why is this important? The thing is, I don't want to talk about inlining per se, but I want to talk about inlining, the combination of inline and cross inline. And so here I have one example. So that code over there looks a bit complicated, but I will explain it. So we've got at the top call engine cross inline, and that is a function. And it is a high order function because it calls another function that is called start manually. That in this example specifically doesn't get used. And then we call introduction there. It also has an implementation. and then that introduction gets passed on also to a higher order function, and then we call intro. So this means that when we decompile our code, we get this. So we get the first part of our code, this is the start of the loop, and then we get a call to introduction, which doesn't get inlined, and then we get the invoke to intro, which then creates another invoke function to this point. So we've got a partially inline code, and we've got different calls, and this is just to illustrate what that inline over there does. Is essentially puts the code, all that code that's being used inside the call engine cross inline in line with main. If we use cross inline by calling start manually, then what we have is we are telling the compiler to make sure that we get all the code inline, including the call to start manually, which we are calling here right now. But what that means is that we get this decompiled code. Everything is inline, except here in this call for introduction, this point over here, where then we get this part of the code that then gets called here to invoke. That's this part of the introduction. And then finally, we get everything inlined over here. So we get the get computer in the back seat, and then all of the stuff that's being cross inlined here gets put in here. But this would happen whether we would use cross inline or not use cross inline. The confusion started when we were using cross inline. Why would we need cross inline, and what is the point of this? Because if we are using a call engine cross inline with inline there, then start manually should automatically be inline as well. So what was this cross inline for? So if we don't put cross inline there, this is what we get from IntelliJ. Cannot inline start manually. It might contain non-local returns. And that is the focus of cross inline here. Because the idea is that we don't make accidental unsafe returns, non-local returns in this case. And what does that mean? So I did another example to illustrate precisely what that means. So here, we've got a simple example where the main function is calling the goToStore, and goToStore is also an inline function. That means that when this code gets decompiled, everything should show up in one single, say, inline code, but we are returning to main, so that never walks out. So yeah, this is essentially simulating walking in a store, making a purchase and walking out. But the analogy here is that the buyer never walks out of the store that way. And so what happens is that if we see how the decompiled code appears, we see that that print line never appears in the decompiled code. What cross-inline can do here for us is force us to only make, to avoid non-local returns. So that means that we are forced to use, in this case, a return to goToStore, which means that we are essentially safeguarding that the buyer walks out simply because we are using that cross inline. So it works as a safety, as a marker, so that we don't make those calls back to main and avoid the rest of the code. And this is as simple as it is. But of course, when we are programming and we see the warnings of IntelliJ and things like that, I think many of us have the tendency of just accepting whatever IntelliJ has to tell us and not really look at the content of what that means. And that this is an important part, and will also led to quite a few confusions in the way we make code with these with these keywords. Now, tail call optimization. Who knows what this is? I'm happy with that. So, tail call optimization. This is something that started in the 50s, and there are lots of languages, especially functional programming languages, that have adopted this. And what it is, it optimizes recursive functions, which we tend to think are, they are complicated, but also very nice to see. They have a nice structure, and we like the way they see, but they are usually not very performant. So what this does is allows us to use tail recursive functions and transform them into an iterative form. So what is the catch and what is the problem? Essentially, when we use tail call optimization, we need to make sure that the functions that we are using, that they are tail recursive. And that just means that the last call of the recursive function is equal to the call, to the normal call of the recursive function. So that's why we have there a call to total weight and a call to total weight. It's the same call, and that means that the last call is the same. So this is a tail recursive function, and we can apply tail-rec to it. So regardless of what this function does, if you're curious, this simply calculates the weight of all the parts of a car, and it goes recursively into all of these parts following this structure to get the weight of the whole thing. And it's just for an example. So what we see here is that I've applied tail-rec to it. I've realized that this is tail recursive, and one of the things is that I was able to use only immutable variables, which is also a thing in Kotlin. As you know, when we are working with Kotlin, it's not very idiomatic to use var everywhere. So what this allows us to do, a tail recursive a function like this that is recursive, that is tail recursive, is allows us to use immutable variables, and it also allows us to use that tail-rec keyword there. What does this actually behind the scenes is, if we decompile this, then this is what we get. We get a code that is probably not the best and the most beautiful code, but this is the most efficient form of that code. So automatically, if we decompile the bytecode to Java, this is what we see. All mutable variables, all happens inside the same function, and it's iterative with a while true, which is, I guess, even in Java, this wouldn't be an acceptable code, but it is the efficient form of using this function and of calculating the whole weight of the car. So why was this confusing? It's because when we saw this and we wanted to use this more often, we also had to change the way we make recursive functions so that we could use tail-rec as well. So to make sure that they were all tail recursive. So that we could use tail call optimization with the tail-rec keyword. Now, this is what I just said. Variables are mutable and algorithm is iterative. Another thing that, this was probably the most confusing thing when we were trying to apply annotations in data classes using the Spring framework, and I want to reiterate, this is all about the Spring framework and the iteration and how it interacts with Kotlin. We started using the annotations the way we were using with Spring, and we realized that some of the annotations weren't working at all, which was strange. So we were trying with gets and sets and different kind of use side targets, and it didn't felt very intuitive what we were doing. So I can give an example here. So for example, this wouldn't work in Kotlin because some of these annotations will get interpreted in a different way using Spring. And why is that? That's because when we are using data classes, we are not using setters, getters, or constructors, or everything happens behind the scenes. So we don't see anything. So what does it mean when we apply these annotations? Do they get applied in a field? Do they get applied in the constructor, in the parameter? It's not clear. It's not clear for us as programmers, but it's also not clear for the Kotlin programming language. So why would we use useSide targets? To define precisely where we want to use them. But there was also another confusing thing. We realized that using field in some was important, and in others it was working, and there was no real reason why it would work in one case and not in the other case. So what is behind all of this is that we missed simply the rules of annotation useSide targets that are in the documentation, in the Kotlin documentation. And I don't know if it's not that easy to find or what actually happened, but I see this also happen in other cases with other colleagues. And essentially the rule is here. If you don't specify useSide target, the target is chosen according to the target annotation of the annotation being used. If there are multiple applicable targets, the first applicable target from the following list is used. Param, then property, then field. So it depends on what the annotation is already, which targets are already assigned to that annotation, and also how many are there and which ones are important to use. So this one was an interesting topic during that presentation by JetBrains, and it generated a discussion. I don't want to take credit for that discussion, but in a way I am also. This generated a discussion that led to the creation of this issue in Kotlin. That what it means is that they are making changes to Kotlin 2.2.0, an experimental feature that will make the use of useSide targets easier. How far is that going to go? I don't know, because I'm not sure when that release will be available. But then probably the useSide targets will be a thing of the past. At least that's what I expect in the future. So here we have an annotation, size, and I think we have seen before. But I want to ask you if you have an idea where size can be applied, where size would be applied. Would it be applied on a param, and field, a constructor? Where do you think it would be? Anyone? Anyone has an idea where this would be applied according to the rules? I know I went probably a bit too fast in that segment, but can anyone guess? Yes, who said that? Congratulations. So yeah, so that is parameters is selected in this case. Oh. So if we don't specify where do we want that annotation to be applied, it will be applied in that case here. Also that is valid also for min. So they are applied here at the parameter in the constructor. So this doesn't have any use in Spring, it doesn't work. But it is following that rule where we expect to find them. And so this is what we see when we apply those rules. We see that because we apply field in min, it gets to the right place. For not null and size, also the same thing is and for column is not needed because column has less of these targets, and so it falls perfectly in the rule where then it gets applied on the field. Now delegates and other useSide targets. So delegation is a great feature of the Kotlin language. It is because we are used to using by val, by lazy, sorry. But that's not the only thing that we can do with it. We can do a lot of things with delegates. And here I have an example where we can apply annotations also to delegates and where it can be useful as well to use. So how can we use this? So I've made an example where I've got an interface here called horn. It's got a function to beep, and I've got a car horn and a wagon horn, and they do different sounds. I'm not going to say those sounds, but the idea is that we have two different implementations, and then we've got two different annotations, a delegate to wagon horn and a delegate to car horn. Then we've got the delegate itself that has an implementation of get value. It doesn't have a setter, but the setter is implicit there, where we set which horn do we want to assign to that delegate. And here we've got a class, horn pack, where we are applying the useSideTarget delegate to car horn. So this could be applied either to car horn or wagon horn, or the sound delegate. But because we are applying delegate to it, then this gets applied to either one or the other. And that's, if we decompile the whole thing, this is what we see. It gets applied to the sound delegate, but not to horn, because we have applied the useSideTarget there before. And bear with me, because there's a conclusion at the end. Then we've got this, which is another example. And in this case, the delegate is a sanitized name. It doesn't matter what it's supposed to do. It is essentially, I'm just creating two DTOs that are using that property. And in one example, I'm doing things right. In the other example, I'm doing things wrong. The first one is okay, the second one is not. But the idea is that we see where these annotations get applied to. So in the first example, it gets applied to the getter of the delegate, where we then get the value by delegate. And in the second example, it gets applied to not the value, but the delegate itself, which means that if we try to validate this DTO, we will get something like this, which is an unexpected type exception. It cannot find a validator for the size of a delegate, which doesn't make much sense. But looking at this, it means that we can apply an annotation to a delegate, and we can apply an annotation to the value of the delegate. And that means that in this example, which is kind of a parallel to what we found useful in our project, we were able to apply a delegate, an annotation, a validation annotation to a delegate using delegate local datetime validation constraint, which I will show the code in a bit. And we'll also be able to apply past to the actual value that is used by the delegate, so what we get from the delegate. So that means that this is where these annotations were applied to, and as a result, this whole validator can be used to validate our delegate. But here I'm just validating if the current country is valid. I've got a list of countries, no particular preference for any country, but just as an example to say if when we are using a DTO that uses a delegate that we want to validate, that it's going to validate not only the value, but also whatever we want to put in our delegate. So in this case, we are implementing is valid for our delegate. And finally, for unnamed classes, yeah, so they have arrived in Java. I didn't know about this. I heard about this in DevOps, and I found it interesting to join to the discussion of this talk, because one of the focal points of the Java versus Kotlin discussion was precisely the fact that we could use unnamed classes, just use a main method in a Kotlin file, and then start a Spring Boot service. And with this, we now have something like this. So in the first example here, we can see that we are using a main function, and in main Java we are using the same thing. there isn't much of a difference. And this comes with the JEP 445 and name classes and instance main methods. Which tells me one thing. There has been a constant friendly competition between Java and Kotlin for a long time, but there's also a lot of synergy between them. What I see right now, and what I've noticed in Java talks and Kotlin talks, is that there is kind of something that binds the two languages together, where Java is becoming very similar to the way Kotlin works. There's no Kotlin coroutines or something like that in Java yet. Maybe with Java virtual threads it will be a different thing. But they are getting together. So that means that, I'm not sure, perhaps the two languages will merge at some point, which could be an interesting development. So what I want to say in this talk is these 5 or 6 aspects now of working with Kotlin are important to understand why Kotlin can be a good option. They're important to understand how the Spring framework works with Kotlin, but also other frameworks, how they work with Kotlin. Because all of this stuff probably wouldn't happen if we would be using Ktor in the first place, for example, if we are using Kotlin. The Kotlin documentation is important so that we are aware of how everything works. So I would say search the Kotlin documentation before doing an extensive search of something else. And I'd say also nothing is perfect, and I think Kotlin fails also in that category. Falls into that category, sorry. And I think recognizing that allows us to be better, to have a positive aspect, to pick up the positive aspects of Kotlin and Java, and think about what can work better for us. And the last point, check if Kotlin or Java are the right language for you and your team, because some teams are used to working with Java, and other teams may like Kotlin better. That doesn't have to be a preference at this point, but it's important to discuss that. And I'd like to ask if any of you has questions about this. Yeah. The? Yeah. Yeah. So the idea in Kotlin, I think this is a generalized idea, is that we don't want to deal with exceptions. We don't want to do try catches, but we do have. There are mechanisms for that. You can use try catch. You can use run catching. You can use all of that, but you don't have that warning. I think you're referring to that from. Doesn't tell you. Yeah. So yeah. So if you want to do that, you can. But yeah, that's also a discussion point. Do we want that or not? Yeah, they're very. You'll find many very opinionated about not using exception handling as much as possible, and then others that will say yes, that this is important, that we need to catch this type of exception because we want to see that error reflected somewhere. But if you just let everything go, you will find those errors also in your server logs, depending on what kind of framework you're using for logging. So. Yeah. Yeah. Yeah, but what I'm trying to say is that you can use that with Kotlin if you want. But you have a point there. You don't get a warning about a particular exception that occurs. So you don't get checked exceptions warning. Is there any more questions?
What's the point of using the tail call optimizations, just a syntax sugar to transform recursive code to in an iterative way, just to gain performance, but maintaining the readability of a recursive code, just to understand the point.
What is the point of tail call optimization? That's a big question. I'll try and answer from my perspective. The point is that we don't get that, like very shortly explained, that we don't get ugly code. So we want to see the recursive code, which is frequently seen as a more readable code. And so if we do that and we use the tail-rec keyword, that magic of using iterative in the background and that horrendous code that we saw.
Yeah, that was my assumption. It's for people that like to see recursive code for readability. Purely
for readability. That's the only reason, because it would create lots.
Under the hood is just an iterative code. Under the hood is just an iterative code.
Yeah.
Simulated with the while true, as you saw.
Yeah. Yeah, under the hood is just iterative code, and you can argue that if we use iterative and we use the whiles and the fors, then you see immediately what's working. But yeah.
Okay, so just a syntax sugar.
Yeah, basically, yeah. I agree with that. Yeah. Anyone, you had a question, I think. What do I think of Kotlin multi-platform? If it's going to replace other technologies. One thing that Kotlin multi-platform is very interlaced with is the mobile development, right?
Also, yes.
Yeah, and so in terms of mobile development, I still can't say if that the two languages can compete with each other. So Kotlin is pretty much in the market of Android applications, which is related to Kotlin multi-platform. So I don't see that happening anytime soon, that Kotlin multi-platform will go away. I think there's pretty much still a big future there. And Android is still using, I think the maximum the JDK says 17.
I think so.
So, yeah. So, yeah.
Okay. Another question. Why Kotlin doesn't have the ternary if statement?
The alternative operator.
Yes.
Oh.
The first thing I missed when changed to Kotlin.
I think the founder of Kotlin has asked the same question. I think somewhere I've read that they recognize that as something that is actually missing. That perhaps wasn't the best decision for Kotlin not to have the ternary operator. Yeah. So, yeah. But in my opinion, yeah, there are times where that could be useful. We use alternatives to that. Like sometimes it's useful to use a take if, and then see if the expression that we use in take if is null or not, and then go from there with the Elvis operator. But it's not the same thing as using the ternary operator, of course. But yeah. Anyone else? I'm not sure if... Wow. We still have 10 minutes. I could show some other examples, like for example, is it? Okay. So what I've got here is a database, a Postgres database. And one of the things that I can show here, for example, is that if I start my service, and if, for example, I simply do a get at this point, then what we find here the first thing is the first element, if you remember from the database, was a screw. So there's no problem in this at this point. But if I let it go and show the second element, we see exactly the problem I mentioned in the first point of the presentation. So we see that I'm getting a null value on a non-nullable field, like this one over here. For example. Another thing that I could show. Like for example, so, I mean these examples are all available on GitHub, and so you could also have a look at them there. But I'm just trying to see, for example, I'm not sure how many of you use the decompiler. One person, two persons. Okay. Yeah. So, yeah. Yeah. So. Yeah, I could, for example, show this one. Wow. Yeah, for example, if I remove, for example, this cross inline, and we can see that, for example, we get the exception as I mentioned before. The problem, it will not compile because yeah, because this it wants to make sure that we don't make non-local returns, and so it's kind of one of those things that we can see here. Yeah. But I'm not sure if there are no more questions. Then yeah, yeah. 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 So you're using Kotlin coroutines but you find them. Yeah. Okay. What I think about that, I actually gave a presentation about that on, in DevOps. It was precisely about that. The thing is, with Java virtual threads, the problem is that you can maybe increase a bit of performance because you're using another yeah, kind of, it's not a lightweight, but you're using a different way of using threads, of optimizing the way we use threads, and they are virtual threads. So it means they have in a general perspective, they have a similar mechanism to coroutines. But the thing is that they still work on blocking mechanisms. And so when we are using JPA and things like that, then you will still get blocked with the database access. If we are using a reactive model, then you are taking the benefit of using anything that's reactive. So if you're using coroutines, that is still a benefit if you need to have an application that performs really well. And so unless Java Virtual Threads can fix that in future versions, and there are already progress in that. The JDK 24, for example, doesn't have any pinning issues anymore. Then perhaps we will not, perhaps we'll go in that direction. But we still have that problem with blocking frameworks like, that use a different, blocking paradigm. I don't know if I could show more examples, but we only have 3 minutes. I'm not sure if anyone is interested in more in seeing any of the example in detail of what I mentioned before. If there are no more questions, then all I can do is say thank you.